Okay, I thought we'd also do number 11 just to make sure you got the idea. If you're still struggling, this will give you some more, help. Again, when we see this, if we want to clearly understand what's going on, one of my suggestions is to write that vertex formula underneath it. Because if you remember, your vertex is your HK, and it always looks the opposite. It always is the opposite of what it looks like. So, like, for instance, your H, if you look right here, people think, they look up here and they think, oh, it's a +1. But no, it's really a -1 because of that subtraction sign. Or you could rewrite it as X minus -1 and see that it's H is -1. Your K looks like it might be a +8, but you really have to think of it as Y minus -8 and rewrite that plus sign as a minus, and so it would actually be a -8 also, so it's negative as well. Now your axis of symmetry is always a vertical line, X equal, and it goes through the X coordinate of the vertex, and so in vertex form that's real quick to get as well. You don't have to go do those formulas like you did in standard form. And then to find your x-intercept, you're going to set the opposite variable of the intercept equal to 0. So y equals 0. That means that your y value is going to be 0, and we need to find the x that goes with it. So if we're going to set y equal to 0, let's go back up to our formula. If y is 0, I'll put a 0 in there. 0 plus 8 is a half times x plus 1 squared. Okay, so that's 8 is a half times x plus 1 squared. And if you remember, we see this square here, and we've got just numbers. We could solve this by square rooting. If I want to get rid of the half, I could multiply both sides by 2 to get that square over here isolated so that I can square root both sides. So 2 times 8 is 16, and then these would cancel out. So I end up with 16 is x plus 1 squared. Okay. Now to solve, I'll square root both sides, and you get x plus 1 is, remember I need to put a plus or minus here because I square rooted, plus or minus 4. So you have two equations. One is x plus 1 equal 4, and one is x plus 1 equal -4. This is the case that a lot of people tend to mess up on. If I'm solving for x, I need to subtract 1 from both sides, and one of them will be x equal 3. So I have two x-intercepts. One is 3, 0. I have another one over here. I'll subtract 1 from both sides, and we get x equal -5. This is one thing I've been warning about in previous sections, that sometimes when you solve and you get these numbers that can be actually put together, it's not a plus or minus the same thing here, is it? We got to be careful. Now to get our y-intercept, we need to set x equal to 0. So let's see if I can fit that in down here. My y-intercept will have x is 0, and then I need to fill in this y value right here. So if I'm going to set x equals 0, that'll be y plus 8 equal 1/2, and then 0 plus 1 inside the parentheses would just give us a 1 squared. So y plus 8 is equal to a half times 1 squared is 1, so a half times 1 would be a half. All I got to do to solve for y is subtract 8 from both sides. Now, a half minus 8, you can probably do that in your head. That's -7.5, isn't it? Or you could say, okay, let's get a common denominator of 2, so it's a half, and if I multiply 8 by 2 over 2, that would be a half minus 16 over 2, which would be -15 over 2, which, or you could put -7.5. I'm going to write it as -7.5 up here because I don't think I can fit a half in there. I mean, the 15 halves in there, so it's -7.5. Here at the bottom, you are being asked to graph the original equation, and what they're giving you is a basic, kind of like a parent function, and then you are just basically trying to, you could use your graphing calculator to do all of these, but one of the things that makes this easy is if you understand what's going on. Let's look at 15, I guess. Y equal -x squared, and then you've got y plus 3 equal -x squared, and then you've got y minus 4 equal -x squared. And what they're trying to get you to see that is if you graph that basic y equal -x squared, y equal x squared would look like this, okay? and the negative is going to flip it upside down. So that's going to flip it down like this. It's going to have points on it like 0, 0. It'll have, in this case, it'll have 1, -1, and 2, -4. And again, you can make a table of values, okay, to get it. It'll have -1, -1, and -2, -4, okay. Now, I really need a better graph than this, but I'm just going to try to explain it, and you could put it in on your calculator and see that this is the case. Now remember, if you're going to put these in on your calculator, you got to solve each one of these for y, and you would just scoot those numbers to the other side by adding or subtracting them. But I don't really need my calculator to do this, and this is the whole point of this. Let's look at this one right here. I'll graph this one in green. What this is telling me, if I think about it, this y plus 3, remember how the HK tells me, let me write it down here, the HK tells me the new vertex, but it also is the horizontal and vertical shift. Okay? So when I see y minus k, this k is a vertical shift. And it looks like it's a plus 3, but I know it's really a minus 3 because of this subtraction sign in the formula. I have to rewrite this as y minus minus 3. So k is minus 3. K is my vertical shift, and it's minus 3. It means I'm just supposed to shift that whole thing down 3. So if I go down 1, 2, 3, that means that green one will actually just be right here. I'll just take those 5 major points that I've got, and I'll scoot each one of them down 1, 2, 3, 1, 2, 3, 1, 2, 3, and you could on your graph paper get a really good graph. Now you need to use a good graph paper. It's just I'm on Coursight, on this iPad and this app, I don't have really a way to do that really well. So I'm just going to give you the general idea. Now for the next one, it also y minus 4 equal negative x squared. If you think about this, there's nothing changed on the right-hand side. All that's changing is over here on the left-hand side. And remember, this is y minus k. Well, if it says y minus k is 4, k is actually 4, and it's a vertical shift. And since it's positive, it's up 4. It looked negative in the equation, but it really is the opposite of what it looks, so it's a plus 4. And so that means that I'm going to take my original equation that I graphed in red, that's the y equal negative x squared that's in red, and I'm going to shift it up 4. So I'd go up 1, 2, 3, 4. It'd be right here. And every single point on this graph would get shifted up 4. So I would have basically, it'd be the exact same shape. It would just be going, I would take each one of these, and I'll highlight in yellow what I'm talking about. I would take each one of these good points that I graphed at the very first, the 1, -1, -1, -1, 2, -4, -2, -4, and I would just scoot each one of them up 4, and I could get a really good graph. And I wouldn't have to try to copy that off my calculator, which might be kind of meticulous anyway. All right, in problem number 17, we're going to graph this basic function y equal negative 2x squared. So I'm going to make a table. Remember, y is negative 2x squared, so I'm just going to make a table of values, and I'm going to always plug in x is -2, -1, 0, 1, and 2. You could go to your calculator to do this. I'm actually just going to fill it in quickly. Okay, so I filled out this chart for this red that I've circled in red, y equal negative 2x squared. I filled out a table, and I graphed from the table. You could have gotten that off your calculator just by plugging it in and going and looking at the table. Now, what about the second equation? I could go do this. I could go make a chart off that, but that'd be a pain. I could also go in my calculator, but I'd have to solve that for y and stick it in and get points, and that would be a pain. The whole point of this lesson is if we can graph y equal negative 2 squared, we can graph this second equation that I'll circle in blue just by thinking about what has changed in it. Well, let me write it down here where we can kind of look at it. And what I'm going to do, and what you should probably do, because you're learning this, is write the formula for the vertex form below it, because we can graph a whole lot easier from vertex form. Now, the only thing that changed from the second equation to the first equation to the second equation is that we end up with an h and a k right here, don't we? And the h and the k is our vertex, but it also tells me how to shift this original red equation that I graphed. This h is a horizontal shift, and if you look at it, there's the x, there's the minus, so what's h? It is 2. H is 2. Since it's plus 2, h is the horizontal, h for horizontal shift. And since it's positive, that means I'm going to move every point right 2. Now there's another thing I'm going to do, and I'm going to do it all at once just to make it a little easier. I have a k here. Here's my y. Now I'm going to rewrite this y plus 1 as y minus minus 1 so it fits the formula. Here's a y, here's a subtraction sign. My k is a minus 1. Now k is minus 1. It's a vertical shift, and so since it's negative, it means go down 1. So what I'm going to do is each of those red points that I originally graphed, I'm going to now graph this second equation in blue, and I'll use blue to graph the second equation since I circled it in blue. And what I'm going to do is I'll take each good point that I have, and I'm just going to move it right 2, down 1, because of this right 2, down 1 here. So right 2, down 1. I'm going to take this other one, and I'm going to go right 2, down 1. I'm going to come over here to the red one that's at like -1, -2. And I'm going to go right 2, down 1. Okay, and I'm going to take these points, -2, -8, and I'm going to go right 2, down 1. It'll end up here. And then I'll take this other one at 2, -8, and I'll go right 2, down 1. Okay? And now to graph the new equation, all I've got to do is do this, and I've got it graphed, and I didn't have to go solve the equation for y. I didn't have to go to the calculator and try to get points and then find them. I could just really quickly move that graph over and graph it that way. This is what is handy about vertex form. It allows us to graph a basic function and then just move points over and make a basic table like we did here and then just do the shifts on it, and it's a whole lot easier to graph that way than it would be to back in the days of no calculators. You would have had to grind all those points out by hand. You would have had to plug in and do by hand the -2, x is -2, -1, 0, 1, and 2. So that this was really a time saver before calculators, but it's still something we want to understand because we can write practically any function in terms of transformations. And so that's something we're going to see again. This is not the first time you're going to see this year. You're going to see it again and again.